through my tool ReSQL, or SQL if you prefer. This is a JSON to relational mapper tool, and the idea is it makes it a lot easier for you to get your JSON files into a relational database. So it could be Postgres, MySQL, anything you like really. It will make it easier for you. So here's the interface and what you'll see when you open it. You'll see there's on the left hand side there's a JSON input section, various ways to get your files in. You've got an open file, a paste, and you can also fetch a JSON file from the internet. And then you've got a tree view or a raw JSON that you can switch between to show your JSON in two formats. The tree view is the usual sort of collapsed format where you can open different arrays and objects and look at a larger file a bit more easily. And then on the right hand side you've got the schema output section, which is going to show the results of the analysis of the JSON. I'm going to demo that in a minute. And on the top right there's some options that I'll go through a little bit later. Okay, so first of all I'm going to open a file. I've got a sample file I've been testing with, which is a very large and complicated JSON file. So if we look at the top section here, you'll see we've got a standard object, and then inside that there's an array called statuses. If you drill down into this, you'll find lots and lots of detailed data, lots of objects beneath it. We've got lots of different character sets and in different languages, emojis, all sorts. And it just keeps on going deeper. You just keep going down and finding nested objects. And these kind of files are really difficult to work with, I find. It's difficult to find the data that you're trying to get out at each part of the structure, and it's difficult to figure out how you can put that into a relational format. But ReSQL makes it easy. We just click Analyze JSON, and we'll get a bunch of tables out from it. We've got the main here, which is the top level of the JSON. You can rename it here to call it something more appropriate for the data. And then it's also automatically added each of the arrays that are in the nested data. So we've got this statuses array, which is sort of the top level, that's got all of the other objects inside it. And then if we have a look in there, you'll see that there's that it's gone through and found each of the results about it. So if we've got just a single object like this metadata, then we'll end up with a metadata result type and a metadata ISO language code, because they're on the same level, they're one-to-one with the statuses object, so they'll end up in the same table. And then if we have something like a user, again, it can have entities inside it, and then the URLs in here, which you can see is an array, so there's more than one of those. So if we look at the URLs table it's generated, you'll see it's also added a foreign key back to statuses, so that it's linked the two together properly. We can preview the data here, and you'll see it's automatically generated an ID for these URLs. By default it uses a sequential integer, but you've also got the option of a UUID as well. So that's all I need to show you here. So mentioning that UUID, you can find the option in here to use that UUID by toggling that on. You can also turn off the foreign keys, and there's some options on the SQL dialect you use as well to usually ANSI SQL should be fine for most purposes, but you've got some of the database specific versions as well. And you've got an option to alter the way that it treats the complex types, whether you're going to break them out into lots of tables, or maybe you want to just simply import the JSON as appropriate JSON columns for the database that you're targeting. So the one thing that remains to discuss is the export formats. So you can export all of these as CSVs. You can do that individually, one by one on the tables here, or you can press this CSV button to get a zip file of all of them. And then you've also got SQL and Python formats. So the SQL one I'm going to show you. it will let you create your tables and insert all the data into your database. And Python will help you automate this in case you want to keep doing it. It will take a JSON-L, which is like a JSON object on each line, ingest that and then process this automatically based on the data that you've got here and the analysis it's done. So that can make it repeatable if you want to do it in an automated process. But I'm going to show you how the SQL works. I think this will be the main use case for this app. So I'll call it sample.zip. Just going to open this sample.zip. And you'll see that it's generated a bunch of SQL files. I'll show you the create tables one here. Yeah, so it's going to create tables and columns for all of the things that we were just looking at in the interface. And then if I look at it's the insert URLs one. Yeah, you'll see it's got the insert statements that we need to put all of that data into the database. So if you run all of these in order, then you should end up with a nice relational schema that's a lot easier to work with than the original JSON. So yeah, that's about it. Let me know if you have any questions, any requests for features or problems that I can help you resolve. Thanks.